line. In the previous class, we represented integers on the number line. Positive integers are represented on the right of 0 and negative integers on the left of 0 on this number line. The distance between any two integers is called a unit distance. Let's make 10 equal parts of the unit distance between 0 and 1. In this way, each of these parts will be 1 by 10th part of the unit distance. If we start with 0, number 1 by 10 can be shown on the number line by taking one part from it. In the same way, two parts can be shown by 2 by 10, 3 by 10, etc. Similarly, by taking 10 parts out of 10, you can show a complete, that is 1. Just now, we have represented rational numbers on the number line. Let's understand in detail the representation of rational numbers on the number line. Suppose we have to represent the rational number -5 by 6 on the number line. Pause the video first and try to represent it on the number line. Let me tell you, here the rational number -5 by 6 is a negative rational number. We know that on a number line, a number smaller than a number is represented on its left side and a larger number on its right. Since the values of all negative rational numbers are less than 0, their positions are to the left of 0. Therefore, the position of -5 by 6 will also be on the left of 0. Let's ignore the minus sign for a while. Now, we see that the numerator 5 in 5 by 6 is smaller than 6. From this, it is known that 5 by 6 is smaller than 1, that is, less than a unit. This tells us that the place of -5 by 6 is between 0 and -1. To find the exact location of -5 by 6, we will divide the distance between 0 and -1 into 6 equal parts. In this way, the distance between any two consecutive parts of these 6 parts will be 1 by 6. The fraction of rational number -5 by 6 tells us that we have to take 5 parts of 1 by 6 distance to the left of 0. This will give us the exact location of -5 by 6. Now, will you be able to represent 15 by 4 on the number line? Pause the video and try it. Let me tell you, 15 by 4 is a positive rational number, so it is to the right of 0. We can write 15 by 4 as 3 and 3 by 4. This shows us that these rational numbers are between 3 and 4. To find the exact location, we will divide the unit distance between 3 and 4 into 4 equal parts. Now, we will show the number 3 by 4, that is 15 by 4, by taking 3 whole and 3 parts of 1 by 4th distance. Now, you will be able to represent any rational number on the number line. Today we have learned the representation. There are equal distances between any two points on the number line shown below. Find out the rational numbers denoted by points P and Q. There are equal distances between any two points on the number line shown. To find this distance, we will subtract the number to the left of it from a number. For example, here 0 minus -1 by 7 is equal to 1 by 7. That is, distance between 0 and -1 by 7 is 1 by 7 units. This tells us that if we move to the left of 0 on the number line, the numbers are decreasing by 1 by 7. Here we are getting point P by moving 1 by 7 distance to the left of minus 6 by 7. So this will represent the point minus 6 by 7 minus 1 by 7 is equal to minus 7 by 7, that is, the number will represent minus 1. Similarly, now you find out which rational number will fall at point Q. Find it by yourself. Next example, represent 35 by minus 8 on the number line. If the denominator of a rational number is negative, first we make it positive. For this, we multiply both the numerator and denominator by minus 1 so that there is no change in the value of the number. This will give us the rational number minus 35 by 8. Minus 35 by 8 is a negative rational number, so its position is to the left of 0. We can write minus 35 by 8 as minus 4 and 3 by 8. This shows us that the position of given rational number is between minus 4 and minus 5. To find the exact location, we divide the unit distance between minus 4 and minus 5 into 8 equal parts. We will denote minus 4 and 3 by 8 means minus 35 by 8 by taking 3 parts out of these 8 parts. Next example, each of points P, Q, R, S denote a rational number of 3 by 2, minus 4 by 5, 10 by 3 and minus 7 by 4, but not in given order. Point Q should neither be at extreme left nor at extreme right. Point R is to the immediate right of point Q. Point P is to the right of point R. Find the rational numbers represented by each point and arrange them on the number line. Pause the video and try to solve this puzzle by yourself. Let me tell you. Let us first arrange the points P, Q, R, S in the correct order from the given information. The first information tells us that point Q should neither be at extreme left nor at extreme right. That is, it must be somewhere in the middle. We can say that point Q will be either at this place or at this place. Let us show these two possibilities as follows. From the second information, we find that point R is at the immediate right of point Q. In this way, we can show the point R at this place or at this place. From the third information, we find that point P is to the right of point R. In this case, point P can be placed to the right of point R, but in this case, it is not possible to do so. So, these types of arrangement are wrong. Now, we will place the remaining point S in the blank. This will give us the order of points SQRP. Similarly, we will now arrange the given rational numbers in the increasing order. For this, we will use the number line, that is, we will represent the rational numbers given on the number line. 3 by 2 is a positive rational number. We can write this as 1 and 1 by 2. Hence, its position is between 1 and 2. To find the right place, we will divide the distance between 1 and 2 into as many parts as the denominator, that is 2 parts. Since the numerator is 1, by taking one of these 2 parts, we will denote number 1 and 1 by 2 or 3 by 2. Similarly, we will denote minus 4 by 5, 10 by 3 and minus 7 by 4. Considering the order of rational numbers and the order of given points, we can now say that point S is the rational number, minus 7 by 4, point Q is the rational number, minus 4 by 5, point R is the rational number, 3 by 2, and point P represents the rational number, 10 by 3. So today we have seen some interesting examples related to representation of rational numbers on the number line.